Dear students, today we shall discuss about, as I have already told you, photoelectric effect. Photoelectric effect. Photoelectric effect. This is very important from examination point of view. You may get long question, short questions and numericals from this. It is very important. So, let us first discuss what is photoelectric effect. What is photoelectric effect? What is photoelectric effect? If question comes in the examination, long question, then there will definitely this part will be there. What is photoelectric effect? There will be one mark for this. What is photoelectric effect? Photo means what? Light. Using light, how do you get electric current? That is your photoelectric effect. When you incident light or radiation on a metallic surface, electrons will be ejected. If these electrons can be moved, then you get a current. So, this is your photoelectric effect. When radiation is incident on a metallic surface, electrons are ejected from it. This phenomenon of emission of electrons from the surface of a metal by incidence of radiation is called photoelectric effect. So, when radiation is, what is photoelectric? When radiation is incident, on a metallic surface, when radiation is incident on a metallic surface, electrons are ejected. This phenomenon of emission of electrons from the surface of a metal by incidence of radiation is called photoelectric effect. This phenomenon of emission of electrons from the surface of a metal by incidence of radiation is called photoelectric effect. So, this phenomenon of emission of electrons from the surface of a metal by incidence of radiation is called photoelectric effect. The emitted electrons are called photoelectrons. The emitted electrons are called photoelectrons. Mainly alkali metals like sodium, potassium, etc. are very sensitive to radiation. So, photoelectrons can be emitted from these metals by visible radiation. Alkali metals like sodium, potassium, etc. are very sensitive to radiation. Electrons are emitted from these metals by incidence of visible radiation. So, sodium, potassium, etc. are very sensitive to radiation, and electrons are emitted from these metals by incidence of visible radiation. If a potential difference is applied to the emitted electrons, a current is produced in the circuit. That current is called photoelectric current. If a potential is applied to the emitted electrons, a current is produced in the circuit. A current is produced in the circuit. A current is produced in the circuit. This current is called photoelectric current. This current is called photoelectric current. Photoelectric current. So, this is called photoelectric effect. Next, we will go to how we can experimentally study the photoelectric effect. Experimental study of photoelectric effect. How can you study photoelectric effect experimentally? Experimental study of photoelectric effect. Experimental study of photoelectric effect. How can this effect? So, in order to study experimentally, what do you need? You need a metal on which, that is a photosensitive material, on which radiation will be incident and the emitted electrons will be subjected to potential difference, so that you will get current in the circuit. So, experimental study of photoelectric effect. Experimental study of photoelectric effect. How can you study it experimentally? It is very simple. You take an evacuated glass ball, radiation will be incident like this. Radiation. This is a quartz window. This is a photosensitive material. Here is the anode. Here is C, here is anode. Photosensitive material. C is a photosensitive material, and here we will apply a potential difference. This will be negative, this will be positive. There will be key, there will be ammeter, and the applied potential can be measured by a voltmeter joined in parallel in the circuit, voltmeter. So, this is the arrangement by which you can study photoelectric effect experimentally. So, C is your photosensitive material. C is cathode made of a photosensitive material. Cathode made of a photosensitive material. Radiation is incident through a quartz window. Radiation is incident on the cathode by a quartz window, through a quartz window. A potential difference is applied. A potential potential difference is applied between C and A, between C and A, cathode and anode, cathode and anode. This is your A, cathode and anode. This is your ammeter, ammeter. The photoelectric current, the photoelectric current is measured by the ammeter, which is joined in series. The potential is measured by voltmeter joined in parallel. So, electrons will emitted from this, electrons they will move towards the anode. So, when radiation is incident on the photosensitive material, electrons will be ejected and they will be attracted towards the anode and will get current in the circuit. This is how you can study photoelectric effect experimentally. Experimental study of photoelectric. This is your experimental study of photoelectric effect. Experimental study of photoelectric effect. Then explanation of theoretical explanation of photoelectric effect. Explanation of photoelectric effect. Explanation of photoelectric effect. Who explained the photoelectric effect? Einstein explained the photoelectric effect, for which he was awarded Nobel Prize. So, Einstein explained photoelectric effect by the help of Planck's quantum theory of radiation. Einstein explained photoelectric effect by Planck's quantum theory of radiation. Planck's quantum theory of radiation. Quantum theory of radiation. By Planck's quantum theory of radiation. According to this theory, radiation consists of small packets of energy. Each packet is called a photon and energy associated with each photon is h nu. According to this theory, radiation consists of small packets of energy, called photons, consists of small packets of energy called photons. Energy associated with each photon, energy associated with each photon is equal to h nu, where h is Planck's constant, nu is frequency of radiation. So, when radiation is incident, interaction takes place between photons and electron of the photosensitive material and electrons get ejected. When radiation is incident, interaction takes place between photon and electrons, between photon and electron of the photosensitive material, of the photosensitive material, sensitive material, photosensitive, between photon and electron, the photosensitive material, and the electron gets ejected, electron gets ejected. So, this is how Einstein explained photoelectric effect by Planck's quantum theory of radiation. And we will go to Einstein's photoelectric equation, that is very important from examination point of view. Einstein's photoelectric equation, Einstein's photoelectric equation, Einstein's photoelectric equation. Einstein's photoelectric equation. So, interaction takes place between the photon and electron. Energy associated with electron, energy associated energy of a photon is equal to h nu. Energy of a photon is equal to h nu, where h is Planck's constant and nu is frequency of radiation. So, that is this much of energy is incident. Electron is electrostatically bound to the atom. So, a part of energy of the incident photon, a part of energy of the incident photon is spent to remove the electron, This amount of energy is called work function of the metal. This amount of energy is called work function of the metal, work function of the metal. The balance amount of energy available is communicated to the emitted electron as kinetic energy. The balance amount of energy of photon, the balance amount of energy of photon is given to the electron as kinetic energy. So, basing on this, Einstein's photoelectric equation is found out. How much energy is incident? Energy incident is equal to h nu. Let the work function of the metal, is equal to W0. Suppose the work function of the metal is W0. The amount of energy required to remove the electron from the atom, the work function is W0. Energy incident is h nu. This is the amount of energy spent to remove the electron. So, balance amount of energy is equal to h nu minus W0, which is equal to maximum kinetic energy of photoelectrons. Maximum kinetic energy of photoelectron. So, mathematically you can write that is half m V max square is equal to h nu minus W0. Half m V max square is equal to h nu minus W0. M is mass of electron, Vx is maximum velocity, half mv max square is equal to h by nu minus W0. This equation is called Einstein's photoelectric equation, for which Einstein was awarded Nobel Prize. This equation is called Einstein's photoelectric equation. This photoelectric equation is called Einstein's photoelectric equation. Half mv max square is equal to h nu minus W0. Now look at the equation. In the equation you see half mv max square h nu minus W0. H is a constant, nu is the frequency of radiation, that is also a constant. If you increase the frequency of radiation, you see, look at the equation, half mv max square is h nu minus W0. W0 is a constant for a photosensitive material. For a photosensitive material, W0 is a constant for a photosensitive material. So from the equation it is clear that with increase in frequency nu, kinetic energy, maximum kinetic energy increase. Similarly, when frequency will decrease, that kinetic energy will be 0. So maximum kinetic energy depends on nu. When nu is increased, kinetic energy will increase. When nu is decreased, kinetic will decrease. When nu is increased, kinetic energy increases. Kinetic energy increases. Similarly, when nu is decreased, kinetic energy decreases. At a particular frequency, the kinetic energy becomes 0. At a particular frequency, kinetic energy becomes 0. Kinetic energy becomes 0. At a particular frequency, kinetic energy becomes 0. Let this frequency be nu 0. Let this frequency be nu 0. Suppose at this frequency the kinetic energy becomes 0. So 0 is equal to h nu 0 minus W0, or W0 is equal to h nu 0. W0 is equal to h nu 0. This frequency where kinetic energy becomes 0 is called threshold frequency. This frequency is called threshold frequency. Threshold frequency for the metal. Threshold frequency for the metal. So what is the meaning of threshold frequency? When the frequency of radiation becomes equal to threshold frequency, then kinetic will be 0. So if the frequency of radiation is less than threshold frequency, no photoelectrons will be ejected, however the intensity of radiation may be. So the minimum frequency below which photoelectric effect is not possible. So you can define threshold frequency. So threshold frequency of a metal, of a photosensitive material, is defined as the minimum frequency of radiation, minimum frequency of radiation below which photoelectric emission is not possible. Photoelectric emission is not possible. Photoelectric emission is not possible. Threshold frequency of a photosensitive material defined as the minimum frequency of radiation below which photoelectric emission is not possible. This is how you can explain Einstein's photoelectric effect and the Einstein's photoelectric equation. Then we shall discuss different characteristics of photoelectric effect or laws of photoelectric emission. Same thing, different characteristics of photoelectric effect or laws of photoelectric emission. Different characteristics of photoelectric effect or laws of photoelectric emission, laws of photoelectric emission. Laws of photoelectric emission, different characteristics of photoelectric effect or laws of photoelectric emission. So, what are the different characteristics of photoelectric effect? The first characteristic is, first one, number one, it is an instantaneous process. It is an instantaneous process. Instantaneous process. It is an instantaneous process. The moment radiation is incident, photoelectrons will be ejected. The moment radiation is incident, photoelectrons will be ejected. There is no time lag between incidence of radiation and emission of photoelectrons. There is no time lag. Lagging of time is not there. There is no time lag. There is no time lag between incidence of radiation and emission of photoelectrons incidence of radiation and emission of photoelectrons. So, this is the first characteristic or first law. Second one, variation of photoelectric current with intensity of radiation. Variation of photoelectric current with intensity of radiation, variation of photoelectric current with intensity of radiation. When intensity of radiation means, when the intensity of radiation increase, number of photons increase. When number of photons increase, photoelectrons will be more, so photoelectric current will be more. So, when intensity of radiation is increased, when intensity of radiation is increased, When intensity of radiation increased, photoelectric current increases. Photoelectric current increases. Photoelectric current increases. However, this frequency of radiation must be more than the threshold frequency. When intensity of radiation increases, photoelectric current increases. If a graph is plotted between intensity of radiation and photoelectric current if you plot a graph between intensity of radiation and photoelectric current, a straight line passing through the origin, a straight line passing through the origin is obtained. Passing through the origin is obtained. A straight line passing through the origin is obtained. You plot a graph between intensity of radiation and photoelectric current, you will get a straight line passing through the origin. Straight line passing through the origin is obtained. Like this, intensity of radiation, photoelectric current, you will get a straight line passing through the origin. More the intensity of radiation, more will photoelectric current. However, the condition is that frequency of radiation must be more than the threshold frequency, otherwise there will be no photoelectric effect. Then third one, variation of kinetic energy of emitted electrons with frequency of radiation. Next characteristic, is third characteristic, variation of kinetic energy of photoelectron with frequency of radiation, variation of kinetic energy of photoelectron with frequency of radiation. When frequency of radiation is increased, kinetic energy increases. When frequency of radiation is decreased, kinetic energy decreases. At a particular frequency, kinetic energy becomes zero. This particular frequency is called threshold frequency, below which photoelectric effect is not possible. When frequency is increased, when frequency is increased, kinetic energy increases. You increase the frequency of radiation, kinetic energy will increase. Similarly, when frequency decreased, kinetic energy decreases. At a particular frequency of radiation, kinetic energy becomes zero. At a particular frequency of radiation, kinetic energy becomes zero. This particular frequency is called threshold frequency, which is different for different photosensitive materials. This particular frequency is called threshold frequency, is called threshold frequency. Threshold, this particular frequency is called threshold frequency. If a graph is plotted between frequency of radiation and kinetic energy, you will get a straight line of this form. If a graph is plotted between maximum kinetic energy and frequency of radiation you plot a graph, frequency of radiation, following straight line will be obtained, 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 following straight line will be obtained. What is the nature of that straight line? Let us see. This is frequency of radiation along this axis, maximum kinetic energy half mv max square, maximum kinetic on this axis. So, what will happen when nu increases, maximum kinetic will increase, when nu decreases, maximum kinetic will decrease. At a particular frequency, this kinetic energy becomes 0. So, the graph will be of this form. This frequency is what? This is nu 0. What is this nu 0? Nu 0 is called threshold frequency. Nu 0 is the threshold frequency. Nu 0 is the threshold frequency. Nu 0 is the threshold frequency. So, below this frequency, if the frequency of radiation is below nu 0, then there will be no photoelectric emission. This value of nu 0 is different for different photosensitive materials. Nu 0. Next characteristics, variation of photoelectric current with applied potential. Next characteristic, variation of photoelectric current with applied potential. Variation of photoelectric current with applied potential, variation of photoelectric current with applied potential. When you increase the potential, what will happen? More and more electrons will be attracted. So, photoelectric current will go on increasing, but it will increase up to a certain maximum value. That means, photoelectric current becomes saturated. Then that saturation value will change if the frequency of radiation is changed. So, if you increase the potential, photoelectric current increases up to a certain saturation value. When the applied potential is increased, increase the applied potential, photoelectric current increases, photoelectric current increases, increase of what? Does it increase indefinitely? No, it does not increase indefinitely. It increases up to a certain maximum value, increases up to a certain maximum value called saturation value, The saturation value can be changed by changing the frequency of radiation. This saturation value can be changed. This saturation value can be changed by changing the frequency of radiation. So, for a particular frequency of radiation, saturation current is fixed saturation value. So, when you increase the potential, photoelectric current increases. Similarly, when potential is decreased, photoelectric current decreases. Similarly, when potential is decreased, photoelectric current decreases. Potential decrease, photoelectric current decreases. Photoelectric current decreases. But when potential becomes 0, photoelectric current does not become 0. When potential is 0, photoelectric current is not 0. Photoelectric current is not 0. When potential is 0, photoelectric current is not 0, because by virtue of the kinetic, electrons can move toward the anode. So, when potential is 0, photoelectric current is not 0. So, how to make the photoelectric current 0? In order to make photoelectric current 0, you have to stop the electrons. So, in order to stop the electrons, potential must be applied in opposite direction, that is negative potential must be applied. In order to make photoelectric current 0, potential must be applied. In opposite direction. Potential must be applied in opposite direction. That means negative potential is to be applied. So, when you apply the negative potential, the electrons are repelled and they are stopped. When electrons are stopped, there is no current in the circuit, photoelectric current becomes 0. So, potential must be applied in opposite direction, that is a negative potential must be applied. That is a negative potential. Must be applied. This negative potential for which photoelectric current becomes 0 is called stopping potential. This negative potential for which photoelectric current becomes 0 is called stopping potential. If a graph is plotted between applied potential and the photoelectric current, following curve is obtained. If a graph is plotted between taking applied potential along x-axis and photoelectric current on y-axis and photoelectric current along y-axis, the following curve is obtained. You will get a curve here. The following curve is obtained. If you plot a graph taking applied potential on x-axis and photoelectric on y-axis, you will get a curve like this. Applied potential along x-axis, photoelectric current along y-axis. So, what will be the graph? The graph will be like this. Graph of this. This is the nature of the graph. This is your saturation current. This current, this is called saturation current, and this negative potential is called stopping potential. This is called stopping potential. So, these are the characteristics of different characteristics of photoelectric effect, or these are also known as laws of photoelectric emission. So, how this photoelectric current depends on potential, how maximum kinetic energy depends on frequency, and that photoelectric effect is an instantaneous process. Now, how this photoelectric current depends upon intensity of radiation. So, from this you can get long question, short question, what is threshold frequency, what is stopping potential, what is photoelectric effect, write Einstein's photoelectric equation, etc. At the same, the most important application of photoelectric effect is in a photocell, and a photocell is used for burglar alarm or switching of street light, etc. There are number of uses of photocell. Photocell, most important use of photoelectric effect is in a photocell, and photocell is used, has got number of uses. You can use photocell for burglar alarm and for automatic switching of red street light, etc. At the same time, along with long question, short questions, objective questions, you will be asked to solve numericals from photoelectric effect. So, you must be acquainted to solve how to solve some numericals from photoelectric effect. So, suppose the question is a photoelectric surface has a work function. Question is numericals. Photoelectric surface has a work function of 4 electron volt. Calculate the maximum velocity. Calculate the maximum velocity of photoelectron. Maximum velocity of photoelectron emitted by light of frequency. So, this is a very normal question. that comes from photoelectric effect, frequency 3 into 10 to the 15 hertz. So, frequency of radiation is given to you, the work function is given to you, you are asked to find out the maximum velocity. So, let us first calculate what is the maximum kinetic energy, then from maximum kinetic energy we can calculate what is the maximum velocity. Half, take the equation, half m v max square is equal to h nu minus w 0. Half m v max square is h nu minus w 0. So, your nu is given to you, h is known, w 0 is your function, w 0 is 4 electron volt. You have to express it in joules. For 1 electron volt, I have already told you 1.6 10 to the minus 19 joules. So, this is your function 4 into 1.6 10 to the minus 19 joules, and so your h is equal to how much? 6.6 10 to the power minus 34. Remember this value of Planck's constant, joule second. Nu is equal to what? 3 into 10 to the 15 hertz. Now, you put the values and solve for maximum kinetic energy, half v max square, that is equal to what? 6.6 10 to the minus 34 into nu 3 into 10 to the 15 minus 4 into 1.6 10 to the minus 19. This one becomes what? 6.6 into 3, 19.8 10 to the power minus 19 minus this becomes 6.4 10 to the minus 19. So, 19.8 minus 6.4 is 13.4 10 to the minus 19 joules. So, this is your maximum kinetic energy. What is the question they have asked? To find out maximum velocity. So, how to calculate maximum velocity? How do we calculate maximum velocity? So, V max square, what is V max square? V max square is equal to 2 into 13.4 into 10 to the power minus 19 by m. What is m? M is mass of electron, that is equal to 2 into 13.4 into 10 to the minus 19 by mass of electron. Remember the value 9.1 into 10 to the minus 31 kg mass of electron, 9.1 10 to the minus 31 kg V max square. So, what is V max? V max is equal to root over of 2 into 13.4 10 to the minus 19 by 9.1 10 to the minus 31 root over of this. So, what will the unit? The most important is, if you do not get time in the examination to solve this, you can keep it like this, but mention the unit. If you do not mention the unit, marks will be deducted. So, unit will be, since it is velocity, unit will be meter per second. Meter per second velocity will be, this is maximum velocity of ejected electron, meter per second. It's simple, you can calculate like this, 26.8 by 9.1 10 to the power how much? 10 to the power of 12 root over meter per second, that is 268 by 91 root over 10 to the 6 meters per second. Leave it like this, maximum velocity of ejected electrons. Another type of question is also asked in the examination, let us discuss that. In that case, wavelength will be given in place of frequency. The question is the photoelectric threshold, photoelectric threshold for a certain metal, photoelectric threshold for a certain metal is 4000 angstrom, wavelength in form of wavelength is given. Determine maximum kinetic energy. Determine maximum kinetic energy of photoelectrons when radiation of wavelength 2000 angstrom is incident. 2000 angstrom is incident. Radiation of 2000 angstrom is incident. So, how do you bring this Einstein photoelectric equation to wavelength form? It is given that photoelectric threshold for a certain metal is 4000 angstrom. Determine the maximum kinetic energy of photoelectrons when radiation of wavelength 2000 angstrom is incident. So, when you solve the problem, first of all read the question, see what are given and what is asked. Here it is given in Einstein photoelectric equation will be used, but in form of what? In form of wavelength. So, what is the equation maximum kinetic energy? The maximum kinetic energy is equal to what? Half m V max square, that is according to Einstein's equation, this is h nu minus w 0. Nu is the frequency of radiation and w 0 is work function. The work function is not given to you directly, nor frequency of radiation is also given. So, how to do it? H nu minus what? H nu 0. W 0 is h nu 0, where nu 0 is threshold frequency. Now, nu and nu 0 they must be brought to wavelength form. So, how to bring them? H c by lambda minus H c by lambda 0. What is lambda? C, velocity of light, lambda wavelength of incident radiation, lambda 0 is threshold wavelength, c is velocity of light, lambda wavelength of incident radiation, lambda 0 threshold wavelength. So, these things are given to you. Now, you have to see how these things are given, in which form they are given. Now, the threshold frequency is given lambda 0. Lambda 0 is given to you in 4000 angstrom. If you put 4000, this will be wrong, because you have to bring it to meters. That is 4000 angstrom into 10 to the minus 10 meter. Lambda is equal to how much? 2000 angstrom. It must be also brought to meter. 2000 in 10 to the minus 10 meter. Now, you can put the values. So, maximum kinetic energy Sc can be taken common, 1 by lambda minus 1 by lambda 0. That is Hc, a value of h 6.6, 10 to the minus 34, c velocity of light 3 into, you have to remember this, 10 to the 8 into 1 by lambda. Lambda is how much? 4000, 10 to the minus 10 minus 1 by 2000 into 10 to the minus 10 minus 4000 into 10 to the minus 10. So, that becomes 6.6 into 3, that is equal to 19.8, 10 to the minus 34 into 10 to the 8, 10 to the minus 26 into what? 1 by 2 10 to the minus 7, 1 by 4 10 to the minus 7. So, 10 to the power plus 7, 10 to the into 10 to the power plus 7 into how much? 1 by 2 minus 1 by 4, 1 by 2 minus 1 by 4. So, this becomes 19.8 into 10 to the power minus 19 minus 26 7. So, minus 19 1 by 2 minus 1 by 4 is half 9.9 10 to the minus 19 10 to the minus 19. Next is what is the unit? The unit is very important, you must mention the unit joules. So, the maximum kinetic energy will be this much 9.9 10 to the minus 19 joules. Like this you can get problems in the examination basing on this equation, but when you are solving the problem you must see which equation will be used, what are the data given, in which system of unit data are given. All the data must be brought to the same system of unit, otherwise the problem will be wrong. If the some data are given in CGS unit, some data are given in MK unit, all the data must be converted to MK system or CGS system and the problem can be solved. Okay, it is all right. Let us stop.